Physics Part 166. We've got exam style questions for this section. Number 1, a student designs an electrical method to monitor the position of a steel sphere rolling on two parallel rails. Each rail is made from bare wire of length 30 centimeter and resistance 20 ohms. The position sensing circuit is shown in the figure. The resistance of the steel sphere and the internal resistance of the battery are negligible. A. State the voltage across 10 ohms resistor when the sphere is at A, where I is equal to 0. B. With the sphere at end B of the rails, calculate number 1, the total resistance of the circuit. Number 2, current in the 10 ohms resistor. Number 3, the output voltage V. Number 2, two equations for the power P dissipated in a resistor are P is equal to RR and PV square over R. The first suggests that the greater the resistance of R of the resistor, the more power is dissipated. The second suggests the opposite, the greater the resistance, the less the power. Explain this inconsistency. State the minimum number of resistors, each of the same resistance and power rating 0.5 watt, which must be used to produce an equivalent of 1.2 kilo ohms. 5 watt resistor, calculate the resistance of each and state how they should be connected. In the circuit shown, the figure, the current in the battery is 1.5 ampere. The battery has internal resistance of 1.0 ohms. Calculate the combined resistance. A. Calculate the combined resistance of the resistors that are connected in parallel in the circuit of figure. B. The total resistance of the circuit. C. The resistance of resistor Y. D. The current of 6 ohms resistor. Well, number 5, the current in the starter motor of a car is 160 ampere when starting the engine. The connecting cable has a total length of 1.3 meter and consists of 15 strands of wire, each of the diameter of 1.2 mm. The resistivity of the metal of the strand is 1.4 into 10 power raised to minus 8 omega m. A. Calculate the resistance of each strand. 2. Calculate the total resistance of the cable. Number 3. Calculate the power loss in the cable. B. When the starter motor is used to stop the car, 700 cc of charge pass through a given cross-section of the cable. Assuming that the current is constant at 160 ampere, calculate how long the charge flows. Calculate the number of electrons which pass a given cross-section of the cable in this time. The electron charge is minus 1.6 into 10 power raised to minus 19 centigrade. C. The EMF of the battery is 13.6 V and its internal resistance is 0.012 omega. Calculate the potential difference across the battery terminals when the current in the battery is 160 ampere. Number 2, the rate of the production of the heat energy in the battery. So you can calculate it accordingly. Number 6, a copper wire of length 16 meter has a resistance of 0.85 omega.